Imagine if just one escalator step suddenly stopped moving. Would the entire staircase crash into itself? Most passengers only see the staircase. Hidden below is an enormous machine quietly coordinating hundreds of moving parts with astonishing precision. At first glance, every step appears independent. That illusion is exactly what makes this machine so fascinating. Here's the common misconception. Escalator steps are not individual machines. They are permanently connected into a single moving system. The secret begins inside every step, where components no larger than your hand determine the movement of an entire staircase. Where does a step actually go after it vanishes from sight? The answer is waiting just below the surface. Instead of disappearing, every step begins an invisible journey guided by rails engineered with millimeter precision. The staircase isn't created by motors forcing each step into place. It's created by geometry itself. Watch closely. Without folding, without hinges, and without electronics, each step changes shape simply by following the hidden tracks. What you've seen so far explains why the steps stay perfectly aligned. But it still doesn't explain why they never collide with one another. Everything you've seen depends on one hidden component that quietly controls every single step. The motor doesn't push individual steps. Instead, it powers one continuous mechanical loop that keeps the entire staircase perfectly synchronized. Before the chains begin moving, the motor's speed is transformed into something far more useful: controlled torque. Every tooth on the drive sprocket must engage flawlessly. Even the smallest misalignment could spread throughout the entire system. Instead of concentrating force on one step, engineers spread the load across hundreds of interconnected components. This hidden loop never truly begins or ends. It simply keeps circulating with extraordinary precision. As the system ages, another invisible mechanism quietly keeps everything under perfect tension. Clearances measured in fractions of a millimeter ensure each step enters and exits the staircase without interference. No single component prevents collisions. It is the perfect synchronization of every mechanism working together that makes the impossible appear effortless. We've uncovered how the drive system keeps every step synchronized. But one final question remains. What would actually happen? Let's imagine the impossible. What if one escalator step suddenly stopped moving? The answer begins with something surprising. A single step cannot simply stop by itself. Every neighboring step immediately shares the load because they are permanently linked together. The staircase behaves less like individual stairs and more like one continuous conveyor wrapped into a staircase. But engineers never rely on chain strength alone. Hidden sensors constantly watch for conditions that no passenger would ever notice. Before anything becomes dangerous, the control system has already recognized the problem. Within moments, the drive shaft is locked, bringing the entire staircase to a controlled stop. Because every step is mechanically synchronized, the entire escalator stops together rather than collapsing into itself. The machine sacrifices motion instantly to preserve safety, a decision engineered long before the first passenger ever stepped aboard. Stopping safely is only half the challenge. Restarting without introducing new risks requires another carefully engineered sequence. Before the first step moves, the entire system quietly checks itself, ensuring every component is ready to operate in perfect synchronization. Now consider a far more realistic failure scenario. What if an object becomes trapped where passengers step on or off the escalator? Instead of waiting for damage to spread, multiple independent safety systems react within moments, stopping the escalator before a small problem. Most riders never notice these mechanisms because the safest engineering is the engineering that quietly prevents danger without drawing attention to itself. Hollywood imagines cascading mechanical disasters. Real engineering is designed so those disasters never have the chance to unfold. Here's the surprising fact. Even after millions of operating cycles, modern escalators maintain astonishing precision. What looks like a simple moving staircase is actually a perfectly choreographed mechanical ecosystem where every component depends on every other. The real reason escalator steps never crash into each other isn't a single invention. It's the combination of Now you know why escalator steps never crash into each other. What machine should we explore next? Subscribe to Hidden Mechanics Lab for more engineering secrets.